let us do worksheet questions in probability. 3 balls are drawn one after another without replacement from the bag containing 4 red, 5 blue, 6 yellow. So altogether we have 15 balls we have. 3 balls are drawn one after another, not at the same time, without replacement. Now the probability of getting 3 different colored balls. So there are, I should get 1 red, 1 blue, 1 yellow. What is the probability of getting red ball? 4 by 15. Without replacement means now there are only 14 balls. And what is the probability of getting blue ball, yellow ball? This can happen 3 factorial times because red, blue, yellow, blue, red, yellow, red, blue. Like that, you can interchange this in 3 factorial ways. In each case, this is the probability. Like that, you will get 6 cases. So simplify this: 5 3 times, 3 2 times, 2 twos, 2 sevens. So this is 4 into 3 factorial is 6 by 13 sevens, 91. So 24 by 91 is the required probability. Option B. Next, a box contains 10 mangoes, out of which 4 are spoiled, remaining 6 are good ones. 4 are spoiled ones. 2 mangoes are taken together at random. If one of them is found to be good, so this is based on conditional probability. What are the event that is already given? One of the mango selected is good. This is the event already happened event. So which event probability is required? Find the probability that the other drawn mango is also good. So required probability is P of B by A, which is P of A intersection B by P of A. What is the meaning of P of A? One of the selected mango is good means one is good means the other may be either a spoiled one or good one. Let us say both are good now. Both are good means 6C2 by 10C2. Both are good means 6C2 by 10C2, or one is good, other is bad, spoiled one means 6C1 into 4C1 by 10C2. Then what is numerator? P of A intersection B? A intersection B means one of them is good, the other is also good, which means both are good. That is 6C2 by 10C2. If we simplify this, you will get 5 by 13. 5 by 13 is the required probability. Option D. A and B are two events having probabilities P of 0. X and Y are two events of a sample space. P of X even. P of X by Y means P of A X intersection Y by P of Y. P of Y by X means P of X intersection Y by P of X. This is given as 2 by 5. From this, P of X intersection Y is equal to 2 by 5 into P of X, which is 1 by 3, 2 by 15. From this, P of Y is equal to 2 times P of X intersection Y, that is equal to 2 times 2 by 15, which is 4 by 15. Now let us find P of X union Y, which is P of X plus P of Y minus P of X intersection Y. So this is 1 by 3 plus 2 by 15. LCM is 15. 5 plus 2, 7 by 15. So option B is wrong. P of y is to 4 by 15. Option C is wrong. Now let's find fourth option. That is P of x bar by y. It's not y bar. So this is nothing but y intersection x bar by P of y. What is the formula for P of y intersection x bar? P of y minus P of x intersection y by P of y by P of y. Now if you substitute all the values, you will get answer as 1 by 2. Option D is correct. Next, a special lottery is to be held to select a student who will live in the only deluxe room available in a hostel. 100 third year, 150 second year, and 200 1 year students, first year students have applied for the room. Each third year student's name is placed in the lottery 3 times. Required probability we have found. Each third year student's name is placed in the lottery 3 times. So there is a chance of 300 and 300 into 3. I'm finding N of S. Because each third year student's name is placed in lottery 3 times means each student has 3 times more probability. 100, 300, 100 into 3. Second year 150 students are there. Each name is placed 2 times. So 300 times 150 into 2. 200 first year students name is only 1 time. So 200. These total possible cases. What is the probability that a third year student gets the room is 300. So 300 by 800. 3 by 8. Option B. Each of the roots of the equation corresponds to probabilities of 3 events of a random experiment. Then those events are dashed. Let us find roots of quadratic equations. Two x into x plus 1 minus 1 into x plus 1. So we'll get x is equal to half, x is equal to minus 1. But these are the probabilities, can never be negative. So minus 1 is not correct. Next 1 by 2 is correct. Probability of any event lies between 0 and 1. Next 3x square minus 10x plus 3 is equal to 0. If you write factors, you'll get 3x minus 1 into x minus 1 is equal to, sorry, 3x square minus 9x minus x plus 3. From this, you get x is equal to 1 by 3. X is equal to 3. Probability can never be more than 1. So this is wrong. This is correct. Next, 6x square plus 11x. Write that 11 as 12x minus x. X is equal to 1 by 6. X is equal to minus 2. No, these are the 3 roots which corresponds to probabilities. Now, which type of events are those? What is sum of probabilities? 1 by 2 plus 1 by 3 plus 1 by 6, which is 1. Sum of probabilities 1, they are exhaustive events. Option D. That x is a discrete random variable corresponding to the number appeared on the face of a Bayesian die when it is rolled. Its probability distribution is given. You have to find variance. We know that sum of all probabilities is equal to 1. Implies when you add all those 0.1 plus 0.15 plus 0.3 plus 0.25 2k is equal to 1. From this, what value of k you get? 0.1. K is 0.1. Now the question is finding variance. For finding variance, we require mean. Mean is nothing but sigma xi into p of x is equal to xi. Multiply the x values with probabilities. 1 into 0.1, 2 into 0.15, 3 into 0.3, 4 into 0.24, 5 into k plus 6 into k. This is nothing but 2.3 plus 11k. 11k is 1.1. So this is 3.4. Mean is 3.4. But the question is finding variance. What is the formula for variance? Sigma xi square into p of x is equal to xi minus mean square. Sigma xi square means square the values of x, multiply the probabilities, and then add minus mean square. After simplification, you get answers 1.93. Option B. Next, when two dice are rolled, n of s will be 36. X is the probability of getting a sum of numbers appear on the die is at most 7. At most 7 means maximum 7. Maximum minimum sum is 2. So 2, 3, 4, 5, 6, 7. So x is the probability of getting this. So what will be the value of x? Probability of getting sum 2, 1 by 36. Sum 3, 2 by 36. 4, 3 by 36. 5, 4 by 36. 6, 5 by 36. 7 will be 6 by 36. And if we simplify this, 21 by 36, which is 7 by 12. So this is the value of x. Y is the probability of getting sum at least once. At least one means p of x greater than or equal to 1. If x denotes, let x denotes number of times getting sum 7. So p of x greater than or equal to 1 means 1 minus p of x is equal to 0. P of x is equal to 0, n is 0, p power 0, q power n. So 1 minus q power n. What is p and q? What is success here? Getting sum 7. Getting sum 7 when 2 dice are rolled means 6 by 36, which is 1 by 6. So q will be 5 by 6. So this is nothing but 1 minus 5 by 6 whole power n. This is y. Now given that y is greater than 6, y is greater than x. So 1 minus 5 by 6 whole power n should be greater than 7 by 12. For what value of n this will be true? For what value of n, or for what value of minimum value of n it will be true? You do by verification. First option is given as 3. Take n is equal to 3 and check whether 1 minus 5 by 6 whole power 3 is greater than 7 by 12 or not. Like that, if you go on verifying the options, you will see that least value of n is 5. Next, a number is selected at random from the set 1, 2, 3 up to 100. Given that, so what is the event already given? Selected number is divisible by 2. Then the probability that event B is, it is also divisible by 3 or 5. So what is the required probability? P of B by A, which is P of A intersection B by P of. What is P of A? Selected number is divisible by from 1 to 100. How many numbers will be there? Divisible by 2, 2, 4, 6 up to 100. 50 numbers will be there. So what is P of A? 50 out of 100. Next, what is the meaning of A intersection B? It is divisible by 2 and it is also divisible by 3 or 5. It should be divisible by 2 means divisible by 2 and it should be divisible by 3 or 5 means it should be divisible by 2 and 3 means divisible by 6. How many multiples of 6 are there? 6, 12 like that up to 96. 16 will be there here. And 2 and 5 means it should be divisible by 10. So 10, 20 like that you have 10 here. And what are the common numbers we have, which are divisible by 6 as well as 10? The common numbers you have to subtract. Divisible by 6 and 10. So what will be the numbers? So 16 here, 10 here, out of which you have to subtract the numbers which are common in this. What are the common numbers in this? 80 will be one common number, 30 will be one common number, 30, 80, 60. These are the numbers present in multiples of 6 and multiples of 10. Sorry, not 80, 6, 15, 90. So these three cases you have to subtract. So 23 by 50. Option B. Next, each of the two boxes P and Q contains 100 chips numbered 1, 2, 3 up to 100. One chit is drawn at random from each box, then the probability that the number on the chits drawn from P is square of the number on the chits drawn from Q. Suppose if you select 1 from here, then I should select 1 from P. If I select 1 from Q, then I should select 4 from P. If I select 3 from Q, I should select 9 from P, because the number that is selected from P should be square of this. Like that, if I select 10 from Q, then I should select 100 from Q. So what is the probability of selecting 1 and 1? 1 by 100 into 1 by 100. Like that, how many cases you get? 10. So 10 into 1 by 100 into 1 by 100 is the required probability, which is 0.1%. Option A. Next, two friends A and B meet every weekend, either at a party or at a sports club. The probability that they meet at a sports club is the probability that they meet at a sports club is 4 by 9. The probability that they will dine together at a party and at the club are respectively 1 by 3 and 2 by 5 on a certain weekend. Probability that they disperse without dining. Probability that they disperse without dining is dash. Now, what are the two cases here? To have a dining, there are two possibilities. They may meet at a party or at a sports club. Now the question is, they should disperse without having dining. What is the probability that they will dine together at a party? 1 by 3. So they should not dine means 1 minus 1 by 3, 2 by 3 into they meet at a sports club is 4 by 9. They are not meeting at a sports club is 5 by 9. So 2 by 3 into 5 by 9 is one probability, or they meet at a sports club is 4 by 9. And they should not dine at a they should not dine is 3 by 5. 1 minus 2 by 5. So this is 10 by 27. Sorry, let us simplify. 10 by 27 plus 4 by 15. Simplify this, you'll get 86 by 130. 86 divided by 130. That is the required part. Next, two persons P and Q are considering to apply for a job. The probability that P appears for the job is 1 by 4. Let us say A denotes the event that P applies for a job. B denotes the event that Q applies for a job. Now, probability that P applies for the job means P of A is given as 1 by 4. Probability that P applies for the job given that Q has appeared. Given that Q applies for the job. That is P of A by B is given as 1 by 2. Next, probability that Q applies for the job given that A applies. So P of B by A is 1 by 3. Then the probability that P doesn't apply for the job given that Q doesn't apply. That is P of A bar by B bar is our required probability. How to find P of A bar by B bar, which is P of A bar intersection B bar by P of B bar. A bar intersection B bar is A union B whole bar. A union B whole bar is 1 minus P of A union B by 1 minus P of B. Everything is known. Of course, P of B is known. From this, we can find P of A intersection B. How to find P of A intersection B? From this, P of B by A is nothing but P of A intersection B by P of A. From this, what is P of A intersection B? 1 by 3 into 1 by 4, 1 by 12. Now, P of A and B you can easily find. How? P of A plus P of B minus P of A intersection B. P of A is known. P of A intersection B is known. P of B you can find easily from this. Apply conditional probability here. This is P of A intersection B by P of B is equal to 1 by 2. From this you can find P of B. Substitute all the values here, then you will get the required probability as 4 by 5. Question A and B are events having probabilities P of A 0.6, P of B 0.4, P of A intersection B 0. Then the probability that neither A nor B occurs means A should not occur A bar and B should not occur B bar. This is the required probability. Neither A nor B occurs means A should not occur and B should not occur and means intersection. So this is nothing but A union B whole bar, which is 1 minus P of A union B, and P of A union B is nothing but P of A plus P of B minus P of A intersection B. That is equal to 1 minus 0.6 plus 0.4 minus 0, which is 1 minus 1, 0. Option D. Next, one card is drawn at random from a well-shuffled pack of 52 cards. The probability that the card drawn is either a face card. Face card means Jack, Queen, Kings. So, how many face cards are there in total? 4 Jacks, 4 Queens, 4 Kings. So, 12 face cards will be there. So, what is the required probability? We have to draw one card, it should be a face card. So, 12C1 by 52C1. 52C1. So, 12 by 52. 4 by 3 by 30. Option B. A and B are two events such that P of A and B is 5 by 6. P of A bar is 1 by 4. So, P of A will be 1 minus 1 by 4, 3 by 4. P of B is 1 by 3. Then A and B are which type of events? Let us find P of A intersection B. P of A and B formula is P of A plus P of B minus P of A intersection B, which means 5 by 6 is equal to 3 by 4 plus 1 by 3 minus P of A intersection B. Now that P of A intersection B is nothing but 3 by 4 plus 1 by 3 minus 5 by 6. LCM is 12. 9 plus 4 minus 10. 1 by 4. What is P of A into P of B? 1 by 3 into 3 by 4. 3 by 4 into 1 by 3, which is 1 by 4. Which means P of A intersection B is same as P of A into P of B, and hence the events are independent events. Option B is correct. If P of A intersection B is equal to P of A into P of B, then the events are independent. Next, box A contains 4 white, 2 black balls. Bag B contains 3 white, 3 black balls. Bag C contains 2 white, 4 black balls. If a bag is chosen at random and a ball is drawn from it, probability that the drawn ball is black. So probability of getting a black ball. We can get black ball from any one of the bag. Probability of selecting each bag is 1 by 3. Let us say I am selecting bag A with probability 1 by 3, and probability of getting black ball is 2 by 6, or that is plus I can select bag B with probability 1 by 3 and the black ball with probability 3 by 6, or I can select bag C with probability 1 by 3 and black ball with 4 by 6. Simplify this, your answer will be 1 by 2. Simplification of this gives 1 by 2. Next, a 5-digit number is formed with the digits 1, 2, 3, 4, 5. So, how many 5-digit numbers can be formed? N of is 5 factorial, which is 120, with no digit being repeated. Now, the probability that the number is divisible by 4. The condition for the number to be divisible by 4 is the last 2 digits of that number should be a multiple of 4. So, what are the multiples of 4? 1, 2, 4, 3, 2, 5. When 1 and 2 are fixed, other than 1, 2, we have 3 digits, we have 3 places. So 3 factorial numbers. Similarly, here also 3 factorial, 3 factorial, 3 factorial. So n of e will be 24. Therefore, p of e is 24 by 120, which is 1 by 5. Option B. A box contains 5 red balls, 3 black balls, and 4 white balls. 3 balls are drawn at random. So, what is n of s? 13C3. Altogether, we have 13 balls, sorry, 12 balls, out of which you have to select 3, 12C3. Now, the probability that they are not of same color. So, probability that they are of not same color is nothing but 1 minus probability that all are of same color. So, all the balls should be of same color means I can select all 3 red or all the 3 black or all the 3 white by 12C3. By simplifying this, you will get 41 by 44. Next, a bag contains 9 identical balls numbered 1 to 9, 9 identical black balls 1 to 9, 4 identical white balls numbered 1 to 4. 3 balls are drawn at a time. How many balls are there altogether? 9 plus 4, 13. So n of s is 13C3. Now the question is, find the probability of getting at least one white ball. See, probability of getting At least one. Always, whenever the question is at least one, we do like this by using complement. This is nothing but 1 minus probability of not getting or probability of getting 0 items. That is equal to 1 minus. Getting 0 white balls means all the black balls you should get. So 1 minus 9C3 by 13C3 is the required probability. And if you simplify this, you will get it as 101 by 143. Option A. Next, when 3 dice are thrown at a time, so n of s is 6 cube. The sum of numbers appeared on 3 dice was found to be 15. So this is event already happened. Sum on 3 dice was found to be 15. Now which event probability is required? 5 doesn't appear. 5 doesn't appear on any one of the dice. Now required probability is P of B by A, which is P of A intersection B by P of. What is P of A? Sum on the 3 dice should be 15. For sum to be 15, I should get 6, 6, 3, which can happen in 3 factorial by 2 factorial ways. That is 3 ways. Sum 15 means 5, 5, 5. This can happen in only one way. So next, 6, 4, 5. This can happen in 3 factorial ways, 6 ways. So for P of A, we have 10 favorable cases out of 216. So 10 by 216. Next, what is the meaning of A intersection B? A intersection B means both the events A and B should happen. That is, sum should be 15 and 5 should not be there in any one of the die. So for this, only favorable cases are 6, 6, 3. 3 cases. Sum should be 15, but 5 should not be there. So 3 out of 216. So 3 by 10 is a required probability. Option B. Next, list 1, list 2 are given. You have to match them. The first one is P of A by B, which is P of A intersection B by P of A. P of A intersection B is given as 1 by 5. P of B we have to find. P of A and B is P of A plus P of B minus P of A intersection B. From this, P of B is nothing but 3 by 5 plus 1 by 5 minus 1 by 3. LCM is 15. 9 plus 3 minus 5. 7 by 15. So 1 by 15 by P of A by B is P of A intersection B by P of B. So 1 by 7. 1 by 7 is not there. P by 5 is equal to 1 by 3 plus P of B minus 1 by 5. P of B is 3 by 5 plus 1 by 5 minus 1 by 3. So which is 4 by 5 minus 1 by 3. LCM is 15. 12 minus 5 7 by 15. P of A by B is P of A intersection B by P of B. So 1 by 5 by 7 by 15. Sorry, 1 by 5 by 7 by 15. So 1 by 5 into 15 by 7, which is 3 by 7. So A should be matched with 5. Next, B. P of B. Already we did. P of B is 7 by 15. I think it should be P of B bar. P of B bar is 1 minus 7 by 15, which is 8 by 15. Next, P of A intersection B bar. P of A intersection B bar formula is P of A minus P of A intersection B. That is equal to P of A is 1 by 3, 1 by 3 minus P of A intersection B is 1 by 5, which is 2 by 15. And the last one, D. P of B intersection A bar. P of B intersection A bar is nothing but P of B minus P of A intersection B. Substitute the values and simplify it accordingly. Match this one with these two. Next, A and B are two independent events. Two independent events means P of A intersection B will be P of A into P of B, which is 2 by 15. First question is P of A bar union B. This is P of A bar plus P of B minus P of A bar intersection B. P of A bar is 3 by 5. P of B 1 by 3. If A and B are independent, then A bar and B are also independent, and hence this is nothing but P of A bar into P of B. So 3 by 5 plus 1 by 3 minus 3 by 5 into 1 by 3. 1 by 5. Simplify this, you get 2 by 5 plus 1 by 3, 11 by 15. Next, second one is P of A by, I think it should be B bar or B. So this is P of A intersection B bar by P of B bar. If A and B are independent events, then this is P of A into P of B bar by P of B bar, which is P of A 2 by 5. P of A union B. P of A plus P of B minus P of A intersection B can be written as P of A into P of B. Substitute all the corresponding values. And the last one is P of B bar. It is not P of S bar, which is 1 minus P of B. So 1 minus 1 by 3, 2 by option B. Next, the probability of a coin showing head is 5, and then 100 such coins are tossed. So number of coins tossed are 100. Let us say X denotes number of coins showing head. Let X denotes the number of coins showing head. So what is the given condition? Probability of 50 coins showing head is same as probability of 51 coins showing head. So what is P of X is equal to R? NCR, P power R, Q power N minus R. So what is P of X is equal to 50? 100 C 50, E power 50, Q power 100 minus 50. This is 100 C 51, P power 51, Q power 49. Now you can cancel P power 50 here. You can cancel Q power 49 here. So 100 C 51 by 100 C 50 is equal to P by Q. What is NCR by NCR minus 1? 100 minus 50 by 50 is equal to P by Q is nothing but 1 minus P. So simplify this. 50 by 51 is equal to P by 1 minus P. Do cross multiplication. 50 minus 50P is equal to 51P. So 101P is equal to 50. P is equal to 50 by 101. Option D. Option D is correct. Next, if a die is rolled twice and sum of numbers appearing on them is observed to be 6. So, what are the event already given or happened? Sum on two dice is 6. What is event B? 1 appears on at least one die. So, you define P of B by A, which is P of A intersection B by P of A. What is the probability of getting sum on two dice as 6? 5 by 36. A intersection B means sum should be 6 and 1 should appear on at least one die. So, what are the possible cases for A intersection B? Sum should be 6 and 1 should appear on at least one die. So, 1 5 5 1. Only two cases out of 36. So, required probability is 2 by 5. Option B. Next, in a college, 40% students study mathematics. So, let us say A denotes event of the student studying mathematics. So, P of A is 40 by 100. And 30% students study physics. So, P of B is 30 by 100. And 20% students attend both the classes means A and B, A intersection B, which is 20 by 100. If a student is chosen at random from the college, the probability that chosen student attend only one class means if he attends mathematics class, he should not attend physics class. Or if he attends physics class, he should not attend mathematics class. So this is the required probability. P of A intersection B bar is nothing but P of A minus P of A intersection B. P of B intersection A bar is nothing but P of B minus P of A intersection B. So this is P of A plus P of B minus 2 times P of A intersection B. P of 40 by 100 plus 30 by 100 minus 40 by 100. So answer is 30 by 100 or 3 by 10. Option A. X and Y are two events of a sample space such that P of X given, P of X by Y given. P of X by Y is P of A X intersection Y by P of Y. This is 1 by 2. P of Y by X. That is also X intersection Y by P of X. That is 2 by 5. And this, what is P of X intersection Y? 2 by 5 into 1 by 2 by 15. And this P of Y is equal to 2 times P of X intersection Y, that is equal to 2 into 2 by 15. 4 by 15. So P of Y is equal to 4 by 15, which is not there in the options. Next, find P of X union Y. P of X union Y is P of X plus P of Y minus P of X intersection Y. So this is 1 by 3 plus 2 by 15. LCM is 15. 5 plus 2. 7 by 15, which is not there. Let us check the last option, P of X bar by Y bar. This is nothing but P of X bar intersection Y bar by P of Y bar. X bar intersection Y bar is X union Y whole bar, which is 1 minus P of X union Y. P of Y bar is 1 minus 4 by 15, 11 by 15. So this is 8 by 11. P of X intersection Y by P of Y is 1 by 2. P of X intersection Y by P of X is 2 by 5. So from this P of X intersection Y is 2 by 5 into 1 by 3, which is 2 by 15. From this P of Y is equal to 2 times 2 by 15, 4 by 15. P of X union Y, P of X 1 by 3 plus P of Y 4 by 15 minus intersection 2 by 15. So 1 by 3 plus 2 by 15, LCM is 15, 5 plus 2, 7 by 15. So P of X bar intersection Y bar is X bar intersection Y bar means X union Y whole bar. So 1 minus 7 by 15 by 1 minus 4 by 15. So 8 by 1 minus 4 by 15 means 11 by 15. 8 by 11 is the answer.